Hello. So for this particular question, uh, this is a question of complex numbers. What is given over here is find the minimum value of mod of 5z minus 3 plus mod of 3z minus 5 if z is complex number. Okay. So for this particular question, what we can do is we can take 5 common from here since the coefficient of z is 5, and we can take 3 common from here since the coefficient of z is 3 over here. Okay, so eventually we can rearrange this expression as, let's say this expression is f of z. Okay, now we can rearrange this function as function of z is equal to 3 times, this becomes mod of z minus 3 by 5 plus, I'm writing it as mod of z minus 5 by 3 plus, now see, 3 times I've consumed over here, so 2 times is remaining, so I can write it 2 times of mod of z minus 3 by 5. Here it should be modulus. Over here. I'm selecting the pen now. Okay, so it is modulus of this function. Okay, so now let's say we concentrate on this function, this particular function, mod of z minus 3 by 5 plus mod of z minus 5 by 3. Okay, so we know that mod of this particular function, we can write it as this is mod of z minus z1 plus mod of z minus z2. I can write it as this is greater than equals to mod of this z1 minus z2. This function minus this function. So if I write this minus this, we'll be getting 5 by 3 minus 3 by 5 as z gets cancelled. Now this is greater than equals to 5 by 3 minus 3 by 5, and equality occurs when z lies. See, what is happening over here is z is actually lying. So this is 3 by 5 comma 0 point, and there is some point 5 by 3 comma 0 over here. Now z is lying on this line segment joining these two complex numbers a and b. Now if z lies from here to here, this function attains its minimum value, which is 5 by 3 minus 3 by 5. Okay, so I can write over here as modulus of z minus 3 by 5 plus modulus of z minus 5 by 3. This is greater than or equals to modulus of, let's say I'm writing z minus 3 by 5 and then minus z minus 5 by 3 modulus. Now this equality occurs, so the minimum value is greater than equals to, if we calculate this value, it comes out to 25 minus 9, which is 16 by 15. So this value is greater than equals to 16 by 15. So the minimum value of this function is 16 by 15 when, so I can write that modulus of z minus 3 by 5 plus modulus of z minus 5 by 3. Now this function's minimum value is equal to 16 by 15 when z lies on the line segment, AB. Okay, AB you can see over here. AB is the line segment which joins these two complex numbers together. So when z lies between on the line segment A and B, including A and B, this function attains its minimum value, that is 16 by 15, right? So the minimum value of this entire function fz would be equal to 3 times of this value, 16 by 15, plus 2 times of modulus of z minus 3 by 5. Now, if you have to minimize this function as well, because this is a non-negative quantity, we have to minimize this function as well. So in order to minimize this function, we can take z as 3 by 5, this point A. Now, if we take z equals 3 by 5, this value becomes 0. So if this is 0, then this function fz attains its minimum value, that is 3 into the minimum value of this function, which is 16 by 15. So we have f of z f of z. Now minimum value, f z's minimum value is equal to how much? 3 times 16 by 15, which is 16 by 5. Okay, so there could be a different question. Find the complex number z for which this particular function fz attains its minimum value. So the particular complex number z for which this function, entire function, is attaining its minimum value would be z equals 3 by 5. Okay, this is a very tricky question, but this is a nice solution for this question. Okay, thank you.